So today we're starting into 4.6. We're going to be looking at the graph of cosecant, and we know that cosecant has a special relationship with sine. It's a reciprocal relationship. So in order to think about this graph, we need to think about the graph of sine first. So if you look at the x values here in the table, these are unit circle angles, so going from negative 2 pi to 2 pi. And if we think about moving around our circle, if we're listing out the sine is the y value. So negative 2 pi is right here. It's the same location as our starting location of 0. The y value is 0. Negative 3 pi over 2 is here at the top. The y value is 1. At negative pi, the y value is 0. Negative pi over 2, the y value is negative 1. At the angle 0, the y value is 0. So now that pattern is going to repeat. So pi over 2 is 1. At pi, we're back to 0. 3 pi over 2, it's down to negative 1. And 2 pi, we are back to 0. So if we think about making a sketch of our sine graph, we could connect it with a dotted line. We'll see how the graph of cosecant relates to the graph of sine. So I'm actually just going to start right here at 0. This is where we normally start for sine, so we're going to go up to that maximum at pi over 2, x-intercept, minimum, x-intercept, so we're still thinking about the 5 key points for sine. Go ahead and connect that with a dotted line. And we're going to do the same thing over here, so just repeating that 0, maximum, x-intercept, minimum, x-intercept. So let's continue that dotted line. So here we're actually showing 2 periods of the sine function because we have 2 complete cycles. All right, let's go back up here and think about what's going on with cosecant. So we know that cosecant is the reciprocal of sine. So if sine is 0, you can think about that as being 0 over 1. So when we do the reciprocal, we get 1 over 0, which is undefined. All right, when sine is 1, that's really 1 over 1. The reciprocal is still 1 over 1, so the cosecant value is 1. When sine is 0, again, it's undefined. 1 over 0 is undefined. The reciprocal of negative 1 is negative 1. This pattern is going to continue. So undefined 1, another undefined, another negative 1, and we end up at undefined. So let's look at these angles where the cosecant is undefined. So on our unit circle, it's here and there, which makes sense. Those are the 2 places that have a y value of 0. Sine is equal to 0. If we do that reciprocal, we end up with dividing by 0. So here's how that's going to show up on our graph. For each one of those angles, because it's undefined, it's going to result in a vertical asymptote. So we're going to draw in vertical dotted lines at negative 2 pi, negative pi. Sometimes what I like to do on top of the y-axis, I'll do the dashed line a little bit slanted so that I can see it. We'll do one at pi and another one at 2 pi. Okay, now there are some points that cosecant shares with sine. So at negative 3 pi over 2, cosecant value is also 1. At negative pi over 2, it's also negative 1. Same thing over here. It's going to share the 1 and the negative 1. And here is the shape. So the shape is going to go upwards like this. And so that curve, those lines are going to get closer and closer to these vertical asymptotes, but they're never going to touch or cross. Those vertical asymptotes are sort of like these invisible magnets that are pulling the curve closer and closer to them. And so we result in a graph that sort of looks like these U shapes. So this is the graph of cosecant, and although we have some dotted lines in there showing the original sine, the vertical asymptotes, you could go back and erase them if you wanted to. You certainly don't have to. Just keep your U-shapes with a solid line, and that's what our graph looks like. So we're going to fill out a few more characteristics. First off, the period of cosecant is the same as the period of sine. So the length of one cycle is 2 pi. So our period is really just this one U-shape. All right, so thinking about the domain. So the domain describes which x values correspond to points on the graph. And notice how all of the x values where the intercept passes through, those are all whole number multiples of pi. So those x values are not included in the domain because the function is undefined for each of those points. So what we can say for the domain is that all real numbers, and we can just write this out using words except whole number multiples of pi. Okay, now for the range. So the range is going to describe the y values on our graph. So notice how we have y values from negative infinity up to negative 1, and then there's a big gap. There's a big jump. So there's nothing that exists on the graph from here to there, but then all of a sudden at 1, then it starts over again and it goes from 1 all the way up to infinity. So range is always thinking about the y direction. We can write it using interval notation, negative infinity to negative 1. We can use this in math, the union symbol. It looks like a U. It also means or, so that helps to explain the jump that we're going to make. So then starting again at 1, it's going to go up to positive infinity. And then the vertical asymptotes, the location of them is going to align with what we excluded from our domain. So the vertical asymptotes are going to be all, I like to use the word whole number, all whole number multiples of pi. All right, now we are going to take a look at the graph of secant. So secant is related to cosine. It is the reciprocal function to cosine. And so we are going to now think about our x values going around our unit circle. And I have them highlighted here. So at negative 2 pi, we can see our cosine value is 1. At negative 3 pi over 2, it's 0. Negative pi, it's negative 1. Negative pi over 2, x value is 0. And then we're back to 0 with an x value of 1. So let's just continue that cycle as we go one more time around. End up in the same place that we started. All right, so now when we think about doing our reciprocals for secant, so reciprocal of cosine, a reciprocal of 1, 1 over 1 is still 1. The reciprocal of 0 is going to be 1 over 0. So we have another situation where it's going to be undefined. Negative 1, undefined, 1, undefined, negative 1, undefined, and 1 again. So now the places where it's undefined, these are at the multiples of pi over 2. So it's a little bit different. It's shifted, just like how cosine is shifted from sine. All right, so looking at our graph here, so like we did before, the dotted line to graph sine, I also like to do that for cosine. So let's think about our 5 key points going from 0 to 2 pi. So maximum, x-intercept, minimum, x-intercept, maximum. We'll go ahead and connect that with a dotted line. So there's one period, and then we'll just repeat that on this other side. Okay, and also notice how the places where our function is undefined, that's through the x-intercepts, because the x-intercept is when y is equal to 0. Okay, now, so the points that our graph shares with cosine, over here at negative 2, it's 1 for both graphs. secant is -1 at negative pi, so it shares that point. Secant is 1 at 0. Secant is -1 at pi. And secant is 1 at 2 pi. So we're going to still think about doing the U shape here, so moving away from the x-axis. And what we'll get on the other side here, if you just graph half of a U shape, it looks like that. The other half is really there. I just stopped my x-axis at -2 pi. So that's what the full graph of secant would look like. So the period is the same as what we said for cosecant. The length of one cycle is still 2 pi. This time our domain is going to be all real numbers except multiples of pi over 2. The range is exactly the same what we said for cosecant. It goes from -infinity to 1. There's a big gap, and then it goes from 1 to infinity. And the vertical asymptotes are those multiples of pi over 2. All right, so we're going to talk about some variations of cosecant and secant, but really quick, I want to show you on your calculator what these look like and how you can get them. So first off, if you go into mode, I'm going to have you turn your mode back to radians. We've been working with degrees all throughout the first unit. You can always go back and switch back and forth modes if you need to. Once it's in radians, let's go into y equals. And let's maybe look at sine first. So let's type in sine x. I want to show you really quick here my window. It goes from -2 pi to 2 pi. In the x direction, the y direction goes from -5 to 5. And then taking a look at our graph here, there we have sine. Okay, in my second y equals, here in y2, for cosecant, we're going to type in 1 divided by sine. So that's how we're going to get the reciprocal of whatever sine is. So if we take a look at our graph, you'll see there are those U shapes just touching the maximum and minimum points of sine. So notice how the sine curve really helps us to figure out the location exactly where the U shape is going to show up. If we go back to our y equals and unhighlight sine, so now that part's not going to show up, or actually you could just clear it out and go back to graph, you're just going to be left with the U shape. And that's what we had on our paper with a solid line. So that is cosecant. Let's take a quick look going back to look at cosine. And secant will be 1 over cosine. So there it's graphing cosine for us. And this is what secant will look like. So see the same thing we had on our paper, kind of that half U shape will just look like that on the edge. All right, so that was the basic introduction to cosecant and secant. So now I need you to take out your math notebook, and we're going to finish up with a few more examples, looking at a few variations of these two. So at the top of your paper, if you would copy down 4.6, graphing cosecant and secant. And then the first equation we're going to look at is y equals 2 cosecant of 2x. All right, so because this function, cosecant, is related to sine, we are going to graph y equals 2 sine 2x first. All right, so if we think about this graph, what we've learned so far with graphing sine and cosine, so we can see that it has an amplitude of 2, and we can also see that there's going to be a period change because there's a 2 in front of the x. So if we think about doing our period formula, which is 2 pi over b, in this case b is 2, so we plug in 2 pi over 2, and we see that we have a period of pi. So we're going to graph 2 sine 2x first. We're going to do that with a dotted line. And then our final step will be to turn it into cosecant, thinking about some of the same things we did in the introduction. So to set up my x-axis labels, I'm going to start at 0, end at pi. We're going to cut this in half so we have pi over 2. This guy here is going to be pi over 4, and then we have 3 pi over 4. On the y-axis, because the amplitude is 2, we want to have that labeled up to 2 and down to negative 2. So thinking about our 5 key points for sine, we've got x-intercept, maximum, x-intercept, minimum, x-intercept. Let's do that with a dotted line. Okay, once we have that, we are going to locate where the x-intercepts are. The x-intercept is where that sine value is equal to 0, and if sine is 0, if we take the reciprocal, we end up with 1 over 0, which is undefined. So we're going to locate the x-intercepts, and we're going to draw vertical asymptotes through our x-intercepts. So let's make a note of that off to the side. Okay, next we are going to take the maximum point. That's going to be the bottom of our U shape. We're going to draw the U shape going upwards like this. Over here, it's going to share that minimum point, and the U shape is going to go down. All right, so this final graph here, just the part there that we drew with a solid line, is the graph of 2 cosecant 2x. So there's really not a whole lot different that we're doing from the graph of sine. So as long as you know how to graph sine and cosine, secant and cosecant are very easy. Draw your vertical asymptotes through those x-intercepts, and then just draw your nice U-shapes. All right, we're going to look at one more example. So this one is y equals negative secant of x plus pi over 2. All right, so similar starting step as the last problem, except secant is related to cosine. So we are going to graph y equals negative cosine x plus pi over 2 first. All right, so a few things we can say here. That negative in front means that it's going to be flipped or reflected over the x-axis. So we want to pay attention to that. We don't see any other numbers in front, which means there's an invisible 1, so it's an amplitude of 1, but it is shifted. It's moving to the left, pi over 2 spaces. All right, and actually let me redraw that y-axis. Because it's shifted to the left, let's make sure that we leave some space to the left of wherever that y-axis is drawn. Okay, the period is based on whatever number here is in front of x. There was not a number in front, so we can assume that it's a 1, which means there's no period change. If you think about doing the period formula, 2 pi over b, if b is 1, the period is going to be 2 pi. All right, so if it's shifted, that's going to tell us the starting location. So the first label here on the x-axis is going to be negative pi over 2, since it's shifted to the left, pi over 2 spaces. All right, then since the period is 2 pi, that just means the distance from start to finish is equal to 2 pi. Another way to think about that, 2 pi is the same as 2 pi over 1, and that's the same as 4 pi over 2. So if you think about negative 1 pi over 2, adding 4 pi over 2, negative 1 plus 4, that's going to end us up at positive 3 pi over 2. So that is the start and the end. And then the other labels we have on the inside, so we have 0, positive pi over 2, and then we could put pi right here. So if you think about counting up by pi over 2s, we have negative 1 pi over 2, 0 pi over 2, 1 pi over 2, 2 pi over 2, and we end at 3 pi over 2. So we want to make sure that we have our 5 labels for the 5 key points. And this is negative cosine. All right, so for the 5 key points for cosine, usually it starts at a maximum, but since it's, hold on a second. Let's just label the y-axis with 1 and negative 1. All right, so since it's flipped over the x-axis, it's going to start down here at a minimum. So it's going to go minimum, x-intercept, maximum, x-intercept, minimum. And go ahead and connect those, making it curved. We'll do it with a dotted line. All right, now our final step, so that's the cosine graph. Our final step, we're going to turn it into secant. So we're going to identify the 2 x-intercepts. That's where cosine is 0. So if we do the reciprocal, it's going to be undefined. So we're going to do a vertical asymptote at 0. We'll do a vertical asymptote at pi. And then we will do our u-shape. So we'll share that maximum point to make that u-shape over here. It's going to look like this. It's just half of the u-shape and half of the u-shape over there. So kind of have a lot going on mine. I'm going to highlight the curves that make up our final graph. All right, so again, this time all we needed to do was go back to what we know about cosine and then do those final steps of turning it into secant. All right, so go ahead and take out a lined sheet of paper. We're going to get your paper set up for your assignment. All right, and this is from 4.6. We're doing page 582, number 25 through 43 odd. All right, so you guys have some time now to get started on your assignment. If you're going to use the online book, you can go to phschool.com. Remember, our web code is AZE1013.